Good evening, morning, afternoon, ladies and gentlemen. So I'm reviewing problem number 20 from our exam, and we are given a capacitor with the diameter of 1.2 meters, a separation of 6 millimeters, and it has a dielectric in between. We're given the dimensions of the dielectric, the diameter and the width, and we're given K. And then we are asked to solve for the total capacitance. So this didn't make any sense until I broke it into three capacitors. So as you can see here, we have C1, and that is I'll explain what C1 is in a minute. And then we have C2 and C3. They're the same size, the same area. They have the same separation between the plates. The only difference is that C2 has a dielectric in between. So showing you this picture makes a little more sense. So we're going to treat this as a three-dimensional, two parallel plate capacitors like this, right? That is what the top and bottom of the sphere is. And so what we're going to do is we're going to pull C2 and C3 out, and we're going to calculate what C1 is. So using this formula for parallel plate capacitors, we find that A, the area of this, is the total area minus the area of C2 and C3. So that section right there. C2 and C3 then are the same, as I said before. Using the dimensions that we got, the radii of both the dielectric and the capacitor, we find the area of the dielectric. And the only difference between C2 and C3 is that C2 has the dielectric constant right there, because it has dielectric. So using this formula, this is how you add capacitance in series. It's just like resistance in parallel. So you solve for C23, and then add that to C1, you get your total capacitance of 1.8 times 10 to the negative 9 farads. And that's C on my exam. And yeah, so there's your explanation. Hope you guys understood it. Enjoy.